Rahim, students, welcome back. This is a paper I'm going to solve now, June 2020, variant 31. So let's start. The question is set of the values, find place in the situation when this condition satisfy. I think in this question, whenever a variable comes in the power, we have to bring it down. We use this property after logarithm. If any variable has a power, the power can come down. So it becomes like this. So this property I will apply. So first of all, I will take a log of both sides. So logarithm of first 1 minus 2x less than logarithm of 5 to power x. Now, because when two functions are multiplying, the rule of multiplying left hand, so I'm showing you logarithm of a times to b. What we do in this situation, log of first value plus log of second value. So there's a reason is multiply. So what is the middle sign here? Multiply. So I can say here logarithm of 2 plus logarithm of 3 to power 1 minus 2x. Step number 2, here no change, but this power will come down due to this property. So I can write it here 1 minus 2x and log of 3 and less than x will come again here down because power. So I hope so up till here, no confusion. But how many x's we have? 2 x's. We have to bring on one side. So log of this 2 and this log of 3 multiply with 1 and with inside. So I got a log of the 3 minus 2x log of 3 and x log of 5. Now, if I bring this part here, so left hand side, I get a log of 2. Even the plus, I can go reverse here, and from here, go backwards, reverse. Okay, because, he asking here exact form. So I can say here 2 times to 3. And x log of 5 plus 2x log of 3. Now, from here, what is common? X and x common. So I get this kind of thing inside log of 5 plus 2 log of 3. And here I got log of 6. So here, this number can go in the power, like a reverse property I'm applying from here. So it becomes log of 5 plus log of 3 to power 2. 3 to power 2 is 9. And now this property reverse. So do you see that same property is applicable in either any end? It can be. So log of 5 times to 9, 45. And now it goes down, but make sure before dividing, sometimes what happens, students, I just tell you one thing. It happens sometime. Okay, this is my final answer. Because you know that whenever you divide by a negative, inequality sign goes there. So inequality sign changes, you know it. So if this value is less than 1, because the log, if the value in the break here less than 1 and bigger than 0, it will give you always negative answer, make sure. So when this negative answer goes there, inequality sign will flip. But here, luckily, this is 45, so not in the middle range. This is just extra part I explained to you. Be careful regarding this. So this is clear. Let's go for next question. Here is saying expanded. Make sure whenever expanding binomial expansion in A2 level, you will need here plus 1, not even minus 1, plus 1. So take 2 common out. If I take 2 common out, this becomes 3x divided by 2. And the power on the top is minus 2. Now, one question some students don't understand, a plus bx. When you take a common out, This is gone, but here no A available. Then A will go in denominator. This is the rule. So same I applied here. I took 2 common. So then I can write like this form. Now, according to algebra, be careful. This power 2 goes on 2 separate, and this power -2 goes on second power separate. So now this is a -2. If it goes in denominator, it becomes 2 to the power 2 positive. And now applying binomial expansion formula is 1 plus, if you remember, formula is 1 plus b to power n, formula 1 plus nb, the product of both nb. Then what? N into n minus 1 over 2 factorial into square of b. And I think we have to expand till power 2, so no need to go further. So starting 1 plus nb. N is this, b is this. You can see nb. So product of the power, the second term. Make sure this negative sign of the b value, don't forget it. I have seen many times students miss this negative sign. Be careful about it. And now this n is power, so n into n minus 1. So same story here, power -2. So -2 and n -2 minus 1 over 2 factorial, and times 2 square of the second value, I mean b. And no need to expand further, enough. Okay, then when we apply it, so 1 over 4, and what he was asking for, that that including x to power 2, you have to expand. So x to power 2, okay. So that complete this minus and minus plus, this 2 cancel out, plus I get 3x. Okay, and then what is this one? -2, this is 3. Okay, do it step by step because chance of mistake. So 2 times 2, 3, and divided by 2 is just naturally from here you got -3 and -2, negative plus. So this means this. So first of all, this is becoming negative. So this, if I cancel these 2, I get simply 3. Okay, so I think clear. So 3 times 2, square of 3 and square of 2. I can write it now, 9x to power 2 by 4. Very, very careful regarding this expansion. 1 over 4 in the bracket, 1 plus 3x. And I get here 27 over 4, x to power 2. Now this 1, 4 multiply inside 1 by 1. So I get a 1 over 4. And then what? Plus 3 over 4 times 2x. Then 27 over 16 times 2x to power 2. And what was the question he was asking? That find extending order of power x up to and including x to power 2 simply for the coefficients. So alhamdulillah rabbil alameen. I hope so the point is very, very clear. The set of values for x, which is validity. So whenever we want to check the validity, we always take this expression, this one we talk about, or even you talk about this one, no issue. Whatever inside we have it, okay? And take this negative sign, and this whole value must be less than and bigger than -1. So -3x by 2 less than 1 and bigger than -1. This is a reason. Some student asked what the reason behind it. Actually, this is convergence condition. Convergence is only possible when your values stay in the limit of 0 and -1 and -1. Otherwise, this is a convergence, okay? Converges. You can have a small test. If you take a square of this 2, you get a bigger number. But if you take a square of 0.2, it give you smaller number, okay? So I hope so you got my point. So that is a reason whenever you take a higher power of a value which is in the middle of 1 and -1, you get a smaller numbers. So I hope so the point is very clear. That is why we talk about 1 and -1, which is between this one, so smallest is a reason, main reason. Now I can split in 2 parts, and I can work out for it and get the values, okay? So set of values is asking anyway. So this 2 goes there, -2 and 3 divides, and 2 goes there. Oh, sorry, this I did not miss minus sign. So whenever it goes negative sign there, so sign will flip. I repeat my words, 2 goes there, -2 by -3, inequality will change same time. This, if this 2 multiplies there, and 2 and divided by -3, inequality will change same time. So you can, this is minus minus plus here, you can see, and ultimately if you check it, so answer is coming bigger than, x value is bigger than -2 by 3. I got it from here. And x is less than +2 by 3. I get it from here. So this is my final answer, okay? Or you can write like x is a modulus of x is less than 2 by 3, okay? So I hope so the point is clear. So you can write any one form, both are okay, all right? So I hope so the concept is very, very clear. Next question, he is asking that express this equation as a quadratic equation of tan. We need to convert whole equation in tan and hence solve this equation from first 2 quadrants. So, you know, student, what is fundamental law? If you recall, tan alpha plus beta, what is the rule? In the numerator, tan alpha plus tan beta, and in denominator, 1 and opposite sign of this plus become minus and product of both tan alpha, tan beta. Same rule I'm going to apply in both sides. So let's start. Left hand side, I can say tan theta plus tan 60 upon 1 minus product of both values, tan theta and tan 60, equals to 2 plus, what is about this one? Because negative in the middle. So same story, tan 60 minus tan theta over 1. Opposite sign of this minus as opposite sign of this plus. So I got a plus and tan 60 and tan theta multiply. And I believe this point is very, very clear. Okay. Now, student, what to do onwards? Because we know that tan 60 is √3. Okay, so that is why I'm replacing. And let's see how to replace the values. So here I got tan theta plus √3. I'm just replacing the values. So √3 times 2 tan theta. Okay. And negative, so it is 2, and is again √3 minus tan theta over 1 plus √3 and tan theta. So this is clear. But he said that make a quadratic equation. So let's see how we can proceed and get our target. So naturally, what is that way? This LCM, I should take right-hand side and then cross multiply. So first of all, take LCM. So 1 plus √3 tan theta. And this whole thing multiply with the 2. So I got 2 plus 2 √3 tan theta and plus √3 minus tan theta. This is done. Left hand side I have as it is tan theta plus √3 over. Lot of patience required in this kind of questions. Okay. Now, what is a technique now we have left? Cross multiply. So we have to do very carefully. So 1 multiply both. Wait a minute. Again, this is, I think I have to drag it up. Okay. And now I can do it easily, that I can do cross. So 1 multiply both. I get here tan theta plus √3. So this multiply with the both. So plus √3 and tan square theta. When this multiply with this √3, we give you 3 only. So 3 tan theta, this is over. Let's talk about this one multiply with the both. Okay. So I got 2 plus 2 root 3 tan theta and plus root 3 and minus tan theta. But when multiply this with the whole values, be careful. I'm going to get it what? Negative 2 root 3 tan theta, because this multiply with that. Now when this multiply with this, root 3 become 3 and 3 outside 2, 6. So I get negative 6 and tan square theta. When this multiply with this root 3 is 3 and I get 3 tan theta. And when this multiply with this, I get a plus root 3 and tan square theta. Now students, what to do? Try to is cancellation. Is possibilities there or not? Yes, I think I can see that this and this same. So I think I can cancel easily. Onwards, we can check it. This is wait a minute, because this is both same side, 2 root 3 and 10 2 same, they're same. They cancel out. Okay. What further left? Okay. I think so. I can write further. So when this 6 tan square negative sign come on left hand side, it become positive. So I'm writing like this. Done. No tan square further. Okay, now how many tan? Tan are, this is tan and this 3 become 4 tan squared, 4 tan theta. And this minus tan and minus tan, minus 3 becomes minus 4. When this minus 4 come left hand side, will become again positive 4. So I think this done, and this root 3 and this 2 left behind. So when it come left side, I get a negative root 3 and negative 2. And I believe it is clear, equals to 0. All right, recheck. Okay, and 3, 4. All right, okay. Now we can say that 6 tan square theta plus 8 tan theta minus root 3 minus 2 equal to 0. Now onwards, yes, student, one thing is here. I just observe now. This root 3 is still there. Okay, we have to cancel these also. So in this sense, then we have what left further? It means root 3 gone. So only 2 left. So alhamdulillah, irram. So this point is clear as well. So it means only negative 2 equals to 0. Negative 2 equals to 0. Now you can see that 2, 8, 6 all are divisible by 2. So I get a 3 tan square theta plus 4 tan theta minus 1 equal to 0. And this is our final form. We got it. Okay. Now let's go for the part number next. And wait a minute, sorry. Here we have to find the angle also. This is missing. So what is technique, students? Here I will apply quadratic formula. And when I apply quadratic formula, I will get what? So tan theta, or I can factorize it. 3 ones are 3. And we know it very well, 3 tans. So 3 and 1. So 3 tan theta. And wait a minute. 3 ones are 3 minus 3. So no, I think it is not possible. So we have to go for quadratic formula. So negative 4 plus and minus b square, 4 square, 4 times 2a and minus 1 by 2a. And a value is 3. Now check it here from, if I apply here, so a value is 3 and b value 4. So is minus 1. I get 2 answers. And make sure the a value I write from a value is 3, b value is 4, and c value is minus 1. Coefficients I take. Okay. And after this, you can show direct answers to examiner. So first answer is 0.2, not answer, sorry. Okay, this one. And second, I'm getting here tan theta is equals to negative 1.5486. So now we can get the, we can apply here because we know that this is a, we have to make a class property. Okay. And tan is positive in first quadrant and third quadrant, and tan negative is second and fourth. But make sure one thing, we have to stay in the limit of 1 to 80 degree first two quadrants. So here simply I will take what is the principal angle? I get it. Alpha equals to tan inverse 0.2153. And this is our, so I will get this angle and this angle. And because this is out of range, so I will not take it. So this is only, and this is out of range. So my answer is coming simply when I take a tan inverse 0.2153. It's giving us 12.2 degree or 1 or 2 because it is for accuracy, no problem. Okay, so I think so the point is very, very clear. 2153 exactly. So we got it, this one correct. Let's go for second question, second part. When I go for here, principal angle, students, so what alpha is equal to tan inverse, don't include negative sign. So tan inverse 1.5486. And I'm getting here, principal angle is 57.1 degree. And you know, this is here, and this is out of range. So this is my answer. So it means 180 minus, so I got 122.9 degree. So theta is equal to 122 point, because always 1 dp. Okay, so I hope so the point is very, very clear. And let's go for next question. Question number 4, we have, he's saying here, so we have equation here, y is equals to e to power 2x sine x plus 3 cos x. And you know what is rule of differentiation, students? All of you know it. Whenever we differentiating two things, d over u and v, so u copy v derivative and v copy u derivative. So e to power 2x copy and derivative of this plus and sine x plus 3 cos x copy into derivative of the u. So u copy and this derivative is coming here and then reverse. Sine differentiation is cos and cos is a minus. So I write minus here, minus 3 sine x. And now this differentiation is I'm writing here, first keep as it is, times to power differentiation. After this, what is a rule? And then because we're looking for x coordinate of this point with stationary point. So we know it means we have to plug in differentiation equals to 0. Or first I simplify and then I do the rest job. So I can see that e to power x and e to power 2x to a common. Okay, what left here? Cos x and minus 3 sine x. So from here, this gone out, and 2 times to this function left behind. So I can say 2 sine x and 6 cos x. Onwards, I can more simplify. This 6 plus 1, 7 cos x. And this negative 3 and plus 2 give you negative sine x. So I hope so up till here, it is very, very clear. Okay, and let's see once again. This is minus sign is okay. Minus 3 is okay. Minus sign is here. Let me recheck. E to power copy. Sine derivatives cos. Cos derivatives minus sign. And then keep the whole function as it is into this. Correct. And after this, this 2 multiply with the both. Correct. And 2 sine and minus. So it giving us minus sign. Okay. So up till here, I hope so. The point is very clear. Onwards, what is approach we have? Onwards, we have to say derivative 0, e to power 2x, and 7 cos x minus sine x. So either first part equal to 0 or second part equal to 0. And you know it very well, e to power 2x cannot be equal to 0. And 7 cos x minus sine x equal to 0. Someone asked me, so why this not equal to 0? Because whenever we have exponential equal to 0, we assume take a log of the both sides to bring exponential power down, but log of 0 is infinity, so undefined. That is why it is not possible. It is not possible. Okay. And here I'm looking for this is a sine goes there, or sine goes there, and cos divide. So I get at 7 cos x equals to sine x, cos divide, and it becomes tan. So tan x equal to 7. And when I make sure, yeah, it's radian mode, make sure radian mode, x coordinate, we have radian mode. And it means convert into radian mode. And when I get tan inverse of 7, it giving us 1.4, 1.43. So alhamdulillahi rabbil alameen, we 1.428 actually. Anyway, we got the answer. So I hope so you have no confusion up till here. Let's talk about next part, determine whether the stationary point maximum and minimum. Okay, make sure whenever we have two functions are, it's not easy job for us. If I have to differentiate again from here, although you can do it same the way we have done up. No problem at all, okay? We can do it the way I've done before. But here we have a flexibility. Second marks are 2 only. This is helping us that no need to go for second derivative. Here we have one flexibility. You know it very well. There are 2 possibilities. If curve has a point of maxima, so this is maximum point. Okay, just before at this point, the line is, they have positive gradient, and this here, it has negative gradient. So, and the other way, if I have another idea that if point of minima, for example, point of minima, okay, so just before here, the line has negative gradient, and just after we have positive gradient. So it means the gradient, because all of you know the derivative is also called gradient. So dy over dx. So we will do from here, okay? And I draw a number line. So 1.43, just before 1.42, and just after 1.44. I hope so you got a point. Okay, we can plug in the values and we can check it, what change comes. Okay, what is the difference coming? We can understand inshallah from here. So let's start. So first of all, at x is equal to 1.42. I'm going to plug in and put in this place of each x. So let's find what's gradient becoming. So gradient equals to e to power 1.42 and 7 cos 1.42 minus sine 1.42. And I'm going to type in calculator. And so first of all, exponential power, and then times 2, 7 times 2 cos and minus sign, wait a minute, sign answer. Okay, and I get answer, 1 minute please, 1.42. Or you can do one thing, because some error is coming. I think we should take some more difference, 4.1 and 4.5. Although what I plug in, not even wrong, but maybe it is very close. That is why it's giving us a different zero answer. So I'll take 4.1, 4.1, 4.1, and 4.1. So I'm typing exponential. It is very clear. Although I type, no need to type, and we can get directly an answer even. Or you can do one thing, type this part only. No need type inside. So what is the logic? I just tell you, 1.41 minus sine of 1.41. And this is answers coming positive. And you know, exponential, any power is positive. So no need to waste time. So I got a positive gradient just before. And now at x is equal to 1.45. So when I get it this one, so let's see what answer come for this point. So 7 cos of 1.45 and minus sine of 1.45. So I'm going to check this, and simply I replace every 1.45. 1.45. It is giving us negative. This is negative into positive, negative answer. So it means just before I'm getting negative, positive, sorry, and just after the point, I'm getting negative. So just before positive and just after negative. So it means it's a very clear approach. This is a point of maxima. So I hope so got a point. If first is negative and second is positive, then point of minima. And all of you familiar that whenever we have these lines, you see, all these lines have positive gradient, all these lines have negative gradient. You can see that this is called a negative gradient. These two are negative gradients. I hope so the point is very, very clear. So it is point of maxima. Let's go for next question, number 5, quotient and remainder distribution. Very easy approach, x squared plus 3. So let's see, 2x to power 3 minus x to power 2 plus 6x plus 3. Check this multiply what to give you this answer. Like x to power 2 into what give you 2x to power 3. So naturally 2x only. So this 2x will come up. And 2x multiply both values, students, I get 2x to power 3, and 2x into 3, I get a 6x. I can't write here. I have to write onwards. And sign changes, and this cancel out. I get negative x squared, and even this also cancel out. And I get a plus 3. Now this x squared multiply what to give you this answer? So negative 1 only. And now check it. When I plug in minus 1, when I plug in minus 1 with the both values, I get negative x squared and negative 3. And changing sign is compulsory, this cancel out. And here I get 6. So alhamdulillah rabbil alameen. And I believe this point is very clear. And plan was to find quotient in the top, and remainder is the bottom, is a 6. So I hope so the point is very, very clear. Now this question, exactly, we have Sifa is asking exact value and using part A. So it is a connected with the previous part. And I tell you before I move, I tell you, for example, when you are dealing like simply 7 divided by 2. So keep 7 inside and 2 outside. 2 3s are 6. We got 1 remainder. So 7 by 2 is a fraction. How to convert in mixed form? So before I do the other one, so let's try to convert this in mixed form, okay? So this top quotient we write first. And then remainder we write in the numerator. And divisor I keep it down. Same process I will apply here. So let's start. So as the same process, the quotient, the remainder comes up. So this remainder 6 will come up. So look the way I'm writing up. And this is 2, this come from here from, okay? So it means x to power 2 plus 3 will come here. And the quotient we write here. So quotient, what we have, 2x minus 1. But logically, logically the sign present plus, but we not visibly present here. But here we have to write visible plus sign. So Alhamdulillah Rabbil Alameen, I hope so you understood how I transformed a long division into a mixed form. So I hope so the point is very clear. Now I'm going to use the same because it has here not a concern. Concern is in the part number 2. So what I will do, students, I need it here. So this value I will okay. So I'm doing it here now, and let's get ready now. So this integration I'm going to do 1 to 3 integration. So let's start. Okay. So now, first of all, I can split them. So 2x minus 1 dx separate with limit 1 to 3, and 6 I can bring outside, and here 1 over this I'm writing square of x and square of one other number. Actually, basically we have formula, if you recall, 1 over a to power 2 plus x to power 2. We need both squares. 1 over a times 2 tan inverse x over a. Hold on, this value in the bracket and this value in the bracket. So this value comes here, and after that, this x by a comes here. And I believe this point is very clear. And the same approach I have to apply here. So what the number, which square give you this one? So naturally, root 3, because square will cancel root, we get a 3 back. Now, what is integration of this? So 2x squared by 2 minus x. Okay, and here, what I can do here, according to rule, 1 over root 3 and tan inverse x by root 3. So this is a whole thing, and you can put limit of the whole, but why waste time? Even write this way or make it even this. This make question easier. So in this way, we can find it. Okay. And 1 to 3 limit, correct. So let's try to simplify. These 2 cancel when I plug in 3 here. 3 square 9 and 9 and minus 3. Upper limit done, minus. Now lower limit, 1 square is 1 and minus 1. This is 0. I got a 6 from here. Now, what about this 6 root 3? Already I have it. So I'm going to plug in the 3. First of all, when I plug in 3 in the place of here, so tan inverse 3 by root 3 minus. And wait a minute. Yeah. And tan inverse 1 over root 3. And wait a minute, this is a mixing up, so bring it down. Okay, now when I use it, 6 by root 3 inside, what is a tan inverse? And make sure this kind of topic we always do in a radian mode. So 3 root 3, you know it, when we divide, it gives us pi by 3. And other one giving us pi by 6. Make sure. Okay, when I type this in calculator or 6 LCM, so 2 pi minus pi, and I get 6 times to 6 over root 3, or you can cancel this 6 cancel out. And I can say that this pi left and 3, root 3. So Alhamdulillah Rabbil Alameen. So I hope so this is very clear. And I'm going to finalize it. So pi over 3, root 3. So Alhamdulillah Rabbil Alameen. I hope so. The concept is very, very clear. All right. Let's talk about question number 6. Okay, topic of numerical solutions. He's saying what a question we have here. We're given a sector. And let's read the question. Question is the shaded region bounded by ATBT, okay, by R given. The area of shaded region is equals to area of the circle. Repeat. Area of the shaded region equal to area of the circle. Now question comes how to get area of the region. First of all, I will make a break. And this angle become X. So job number 1, I will use this right angle triangle, students, 90 degree, A, O, and T. There's a radius and there's a X. So first of all, I will find AT. So in front of angle is called opposite. So opposite by adjacent give you tan theta. So AT becomes R tan X. So it means this length I got it R tan X. Now, what is the plan? If I get area of the one triangle into 2, I get a full area. Okay. So plan of action is what? This triangle area into 2, I get a full area minus sector area. Okay. So, and equals this is an area of the shaded part. I repeat, area of the one triangle into 2, I got an area of the full shape. And from full shape subtract sector area, I get shaded. So I hope so clear. So now let's apply a formula, half into base into height. This is called base and this is called height. So R times 2, R tan X into 2. And this 2 and this 2 will cancel out and minus half R squared theta. Theta is again 2X. Now is a circle area. So left part is completely done, alhamdulillah. Now circle area is a pi R square. Now, here I get what R into R become R square tan X and minus half, this half cancel out. So I can say that, so this 2 cancel out, I get R square X. Pi R square. Divide whole equation by R square. I can get easily tan X minus X equals to pi. Bring on the other end. So alhamdulillahi rabbil alameen. We have done it. It's approved. So I hope so this point is very clear. So let's go for next part. This equation has a 1 root in the interval, this one, he mentions. So by calculation, the root lies between 1 and 1.4. So students, what is technique here? First of all, we have 2 choices. Either bring tan on the right-hand side or bring this on the left-hand side. So I can do it anything. So I bring, so f of x is pi minus pi plus x minus tan x. I brought this value here. Okay, I got expression and I converted. So now I replace every value by 1 and 1.4. And I replace every x by, first of all, 1. And then I replace every x by 1.4. I'll just check the signs. Okay, students, so let's start. When I type first one, look, I'm just trying to do it, 10, 1, and make sure radian mode. I get plus 2.58. And second one, when I plug in, I got 1 point, it is coming negative 1.25 anyway. And I always give this idea. It means that, let's say this is a curve and the curve is such that a curve is you can say that is like that. And here 1 and here 1.4. And against 1, I am getting positive answer. And this is a 1. And against 1.4, I'm getting negative answer. You can see that signs are matter or signs matter only. So this is just for confirmation. And this point, so this point is called root or it's called solution. So I hope so you can say a statement as sign changes, so root lies between 1 and 1.4. So that's it. So this part is clear. And let's go for the next part. Now he uses iterative formula and I have to, and he did not given here any initial value. If he gives, okay, fine. Otherwise we take the average of these two numbers. If I take the average of two numbers, students, x1 equals to 1 plus 1.4 divided by 2. And I am getting 1.2 is the average. So I hope so this part is very clear. And now I can start it. So put n value equals to 1, where 1 here and 1 here. So equation will turn, because 1 plus 1 give you 2, x2 equals to, we have this coming tan inverse and pi plus x1. So this 1.2 I will plug in here. So it means x2 equals to tan inverse and pi plus 1.2. And I'm getting x2. And he mentions that the result of each iteration is a 4 dp, but final answer is 2 dp. So now I'm typing in my calculator tan inverse then 1.2. I'm getting 1.3, 4, 4, and 4. First I plug in N1, now I'm plugging 2 again here, again here. When I plug in 2 there, 2 plus 1 give you 3. So x3 is equals to tan inverse pi plus x2. And I'll plug in this x2 here. So I believe you're understanding the concept. And tan inverse pi plus 1.344 and 4. And I can get my answer from here, x3. And answer is coming 1.3515. Okay, when to stop? This is a very important question we have. It depends upon repetition idea. So now 2 dp, look 3.5, it is a, you can see there's a 3.5, 3.4. It's not repeating, still is a there difference. I put a 3, I got an x4. Now I'm going to put it 4 directly, not even directly, that we can show working even, because he said that show the working. Anyway, I will plug in this value 3515 directly from here to here, and I get what? X4. X4 I'm getting is 1.3518. Now it starts repeating. Now from here we can guess it. And just for secure, if I plug in N4, it will give my final answer. And S is a tan inverse and pi plus 1.3518. I get fifth value is 1.3518. It means the answer is 1.35, which is our final answer. And I believe the point is very, very clear. Let's go for next question. So next question is here. So function f of x is given. So we will find derivative. So f dash of x, and here we have to apply quotient rule. Quotient rule is what? Whatever u over v, if we are differentiating. So denominator always squared, this will squared. And which I square keep as it is, derivative of the numerator minus, not reverse. So it means I'm going to square it. Which I squared, I keep as it is. And the differentiation of the numerator, minus sign. Minus formula, you can see. And cos x copy now. and differentiation of denominator, 0 plus cos x. And what question he says, show that if differentiation is less than 0 for this interval. So let's see, first of all, I will multiply with this one. So negative sine x. So this into this, negative sine square x and negative cos square x. And down I have 1 plus sine x whole square. Now, this is, if you take a negative common, I get sine square x plus cos square x. And all of you know this is a sine square x plus cos square x is 1. So I get negative sine x, negative 1 over 1 plus sine x to power 2. Take negative common from the top. So I get a 1 plus sine x over 1 plus sine x whole square. And so this is fully cancelled. So I get finally that negative 1 over 1 plus sine x. Now, what a statement here. He's saying that f dash of x is less than 0, is negative for all interval values from negative half pi to plus 3 by 2. So let's see, negative half to plus 3 by 2. So if I go this way, this is called negative 5 pi by 2. And till what? Till 3 pi by 2. And it means this, that if I go this way, and it also 3 pi by 2. So it means this, he talk about all quadrants. And we have to look upon what is a value of this one sine x. Make sure in first quadrant sine is positive, here sine positive. So, but here sine negative, here sine negative. And make sure even in the middle of the quadrants, so sine x value, highest value +1, lowest -1, or in the middle. So it means we can say clearly, because this is a, if I take a 1 or even like a -1, okay? So that is undefined on the lines. You can skip that part where it is a, because he said that interval for all interval is in the middle here. So this is not included. And like a sine 0, at this level, sine is 0. If a 0, this is a positive. And here, sine also 0. So I hope so, clear point. And so in the middle here, we have all less values. So it means short story, you can say here, for any value of x, for any value of x, sine x will be naturally less than 1 and bigger than -1. Okay, so it means this will become will remain whatever, but this when I add 1, so even add 1 in a with small value, even this sign is negative 0.5, for example. If I add this, give you positive answer. And it means I can say that this is a, so this remain positive, is positive. And positive into negative is a negative. Hence, we can say that this is less than 0 and proved. So I hope so. The concept is very clear. Show that derivative of this is a less than 0. It means it is negative always. So B part we have here, integration pi to 6, pi by 6 to pi by 2. And this function will come throughout there. So cos x 1 plus sine x dx. And he asked exact form. So basically what we have formula, if you recall, function in denominator, differentiation in numerator, and the power of function is 1. So this kind of thing, we can write logarithm of function which is in denominator. So this automatically eliminates. So this is a rule we have. So check please, what is differentiation of 1 plus sine? Do we have up or not? Yes, we have. This has 0, this has cos. So 0 plus cos, it's same. So it means we have function down, differentiation up, and whole power is 1. So we can apply logarithm. So logarithm of 1 plus sine x, and limit pi by 6 to pi by 2. So first I plug in pi by 2 here. If you type all together in a calculator, then you will not get your exact answer. So make sure when you will plug in one step by step, one by one. So look at here. So I hope so up till here clear. And log 1 plus sine pi by 2 is 1. So I'm writing 1. And this is a sine 30 is pi by 6 is sine pi by 6 is half. So here I'm getting log of 2 minus log of 3 by 2. So now I'm expanding. And here, when I expand, so here comes log of 3 minus log of 2. Expand the bracket, minus into minus plus. Log of 2 become 2 log of 2. And this 2 comes in a power. We get a ln 2 to the power 2, which is 4. And this is my final answer. So I hope so point is clear. Let's talk about this question. A certain curve as such a gradient is given this. It's a gradient. Gradient is called derivative. Is proportional to this. All right. Whenever we remove proportional sign, we get k. All right. And he says, first of all, is topic of differential equation, you see, and we have to make a x subject in term. So what few steps we have? Step number 1, separation of variables. So separation. Number 2, we will go integration with a plus c. Third, find c. And fourth, make a subject. What is required? So first of all, cross multiply, students. So this multiply there, or you can bring only dy and k times to dx over x root x. This y comes under it, so I can split same time. All y left side, all x right hand side. After this, what is the next plan? I have to, this is a half plus 1, 3 by 2, because power x 1 and half plus 1, 3 by 2. So k x to power 3 by 2 comes up, negative 3 by 2. Now I'm doing integration here. So integration left side and integrating right side. You keep k outside or keep inside, no issue at all, because constant. So what is here? Logarithm of y and k, increase a power by 1. So negative 3 by 2, when I add, I get a negative half, divided by same and plus c. So this turned to be log of y, and this flip because 1 over 1 by 2, it flips, becomes 2. So negative 2k, and this negative half I can bring in denominator, become positive half or positive root. So it is better to convert in this form. It makes easy to solve, because negative half and I bring in denominator become positive half, and half is called root. Now I can see that 1, 1. So I will plug in 1, 1. So put x is 1, y 1. So when I plug in 1 here, students, it becomes ln 1 minus 2k over root of 1 plus c. This is 0. So I get 0 is equals to -2 and plus C. So C value becomes 2K. This value I plug in back here, equation number 1. So when I plug in there, I get ln y equals to, the C, yeah, C. So 2K over root of x and plus 2K. So C gone. Now I'm going to plug in second point, which is 4e. So put x is equal to 4 and y is equal to e. Okay. So when I plug in 4e here, ln e and minus 2k over root of 4 and plus 2k. ln e is 1 and this is root for 2. This is cancel out and we get -2 only, -2k and plus 2k. Yes, we have to check here. Wait a minute. Yeah, this is a because it is so k plus 2k and k value is 1. So recheck. I think this part is clear. K value is 1 and that plug in back in equation here. So we get logarithm of y is equals to 2 -2 over root of x and plus 2. And now we have to just writing last form. He said convert into the form of big Y subject only. This log is extra and you know it very well. Whenever we can write logarithm y. And I said many times, for example, any number I want to convert into log form, 7 into 1 convert ln e because ln is 1. This number goes in a power of e. So it means we can write any value if I want to write in a log form. So this is a way. So it means 6, we can write ln e to power 6. And same way, this whole thing we can write ln e to power -2 over root x and plus 2 in a bracket. Now log cancel out from both sides. So alhamdulillahi rabbil alameen. This is our final form which he was asking us. So that's it. And let's go for the next question. Okay, next part we have still describe what happens to the y x tends to infinity. When x tends to infinity, what happens? X tends to infinity. So let's try to plug in y equals to e to power -2 over infinity root and plus 2. Yeah. And you know, students, something by infinity, something by infinity is 0. Okay, even if it has a root, even becomes 0. So it means this this is a -2 by infinity plus 2, and in a short way I can say 0 plus 2, and answer is coming e square. So alhamdulillahi rabbil alameen. I hope so. The point is very, very clear. And let's go for the next part. Next question. In next question we have here vector topic. And he mentions here that using scalar product show that angle ABC is right angle. The middle letter is B. And actually I have to prove that this is a right angle. I mean to say, so this is a 90-degree and B letter in the middle. You can write A and B and C. How to prove it? We have a special product is called scalar product or it's called dot product. But first of all, we need what? B to A vector and B to C vector. So let's start. First of all, BA vector I'm looking for. And what is V OA minus OB? OA minus OB will give you BA vector. And what is OA here? I'm writing 2, 0, 5. Actually, it's no J, so I'm writing 0. And OB is 3, 2, 3. You can see the coefficients of IJK. So 2 minus 3 giving you -1, and then -2, and then 2. So BA, I got it. All right, same way I can go for BA. I got it now, BC. So BC vector. So OC minus OB. Where vector ends, we start from there, and then OB come at the end. So I hope so clear approach. OB minus OA, and here is my answer. 1, 1, 1, I got it from here, and OB is 3, 2, 3. I get -2, -1, and -2. So I got BC, I got BA, and I'm using dot product formula. BC dot BA, actually BC magnitude into BA magnitude into cos of angle between them. So this dot product here, magnitude into cos of theta. So BC is what? -2, -1, -2. BA is what? -1, -2, and 2. And what is a modulus? How to find modulus or magnitude? Square, 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 and add them. So -2 square is 4, then 1, then 4. How do this one? So square each number and add them. So I get a what? 1 plus 4 plus 4. And dot product means corresponding position elements, multiply always and add them. So I get simply here, so I get it here 2. I got it +2. I got it -4. And as you can see that, because actually this is no need to do it, but just for sake of understanding. And we got it here 0, and make sure if this 0, whatever here, 4 plus 9 with 3 into 3 and cos theta. And you can see here, so this is coming 0, left side cancel. I got a 0 equal to 9 cos theta. So here 0 is equal to cos theta, and take cos inverse, and answer is turned to be 90 degree. But it's a long working. We can find simply dot product. You can see that this 0 came from there, from here, from here, from here. I mean dot product. So no need to write a right side formula. Simply take left hand side formula and multiply. I mean to say, take this multiply. If answer becomes 0, it proves that the angle is 90 degree. So no need to show even this formula full and the whole story. I hope so got idea. Simply BC dot BA, if answer becomes 0, prove that angle is 90 degree. Anyway, I explain you the full idea in detail. Show that ABC is an isosceles triangle. What is a way ABC? It means that how to prove it? Indefinitely in front of 90, this length always different. Okay, so this length can be, these two lengths can be same. If I find the magnitude of this equals to each other, then and we can see that this is coming same. So look at here. It means this come from here and this come from there. And I got it already here. We can say that as BC magnitude is, we can show like this. So 4 plus 1 plus 4 equals to 3. And then you can show that BA magnitude is equals to 4 plus 1 plus 4 equal to 3. And as they equal, BC magnitude and BA magnitude are equals to each other. So hence we can say that, hence triangle ABC is an isosceles triangle. Okay. I hope so the point is very clear. Right, let's go for the next part. Find the exact length of the perpendicular from O to the line BC. So it means O to line BC, we have to find it. And O is actually, O stand for origin 0, 0, 0. Okay. And BC line, we need it. BC line. So let's say B is here somewhere and C is somewhere here. And this is 90 degree, and this is called F, foot of perpendicular. And we have to find out the exact length of this one, OF. So student, first of all, we're looking for equation of line BC. So vector equation of line, vector equation of line BC. We have two ways to find it. R is equals to OC plus lambda time to CB, or I can say R is equal to OB plus lambda time to BC. But make sure one thing, this letter same, so this must be same, and this must be same. So anyway, I use a lower one, and I think we have a BC already mentioned here. BC we have here. So, and B is what, students? 3, 2, 3. 3, 2, 3. So I'm writing here 3, 2, 3. 3, 2, and 3. Plus lambda times 2 BC. And BC, I just got it here. You can see BC is here. -2, -1, and -2. Okay. And convert standard form of line. Standard form of line. So when I convert standard forms, it turns to be this way. So this is 3 and this -2 lambda. I coefficients, I'm just collecting together. Similarly, J coefficient. So it means the 2 minus lambda and 3 minus 2 lambda. Anyway, you know, when you convert any line in standard form, it represents million trillion points lie on the line. Even it expresses F also. So I mean, says we can say that OF is also same. This is expressing the coordinates of OF, of F point or a vector form. Anyway, and what is story now? Because 90 degree, and at this particular point, 90 degree, it means OF vector and line direction is dot product equal to 0. So I can say that OF dot line direction, and line direction is what? Actually, line direction is here. In this particular question is BC. So OF dot BC equals to 0. So let's try to find it. OF is 3 minus 2 lambda and 2 minus lambda and 3 minus 2 lambda. And BC is, I got it, is line direction is this, -2, -1, and -2. And dot product, you know, students, corresponding elements multiply I, j, and k. So I get -6 plus 4 lambda, -2 plus lambda, -6 plus 4 lambda. 4 plus 5 plus 4, 9 lambda. I get 9 lambda. 6 plus 2, 8. 8 plus 4, 14. So 14 goes there, and lambda becomes 14 by 9. Now, what to do, students, here? So we got a lambda value 14 by 9. Or, just a minute, please. 4 minus plus. And this is, yeah, 4 plus 4. Let's recheck once again, because it is coming some. Okay, let me recheck. So is all okay, students? There's no any mistake. So I think all clear. Mostly this question, this number come in fraction, in a whole number, but it can be fraction form even. Anyway, now we will plug in this lambda value. We have two choices. We plug in lambda value in this place and get a OF F point, and then we can find the distance between OF. But luckily this 0, 0, 0. So it means the distance between, for example, what are coordinates of F? So there the same answer comes. So I mean to say, I will find lambda by this 9 in the place of this all. So let's foot of, sometime he asks you foot of perpendicular, and I'm going to find foot of perpendicular. So when I plug in this value here, so let's type in calculator 3 minus 28 by 9. It's coming -1/9. When I plug in this value here, so it means 2 minus 14 divided by 9. I got 4/9. In the last form, I get again -1/9. So I got an OF now. I'm looking for the OF length. So I can use the distance formula. And you know, F coordinate, these are called F coordinates. So when I find we can find that way, or simply find the magnitude of the whole thing. So same story. This is formula. How come? You know, this X coordinate minus X coordinate whole square, you know, Y2 minus Y1 whole square plus Z2 minus Z1 whole square. So that same thing, I'm doing it here. And now I'm typing in calculator. So in root 1 divided by 81 plus 16 divided by 81 plus 1 divided by 81. And answer is coming here, root 2 over 3 units. So alhamdulillahi rabbil alameen, the concept is clear. Complex number question we have now, and what our question is, we have given here u is equal to this one, and he said convert into Cartesian form. So how to do Cartesian form? We have one choice only, and that is called rationalization. How to rationalize? What is in denominator? Take the conjugate. So what is iota sign plus? Make it negative. This is called conjugate of the denominator. And multiply up and down, this is called rationalization process or rationalize. Okay. So what is happening here? So I can multiply with this, okay? I can say here 3a iota, and this multiply with that, I can say minus 6 iota to power 2. Denominator, I can multiply same way, or I can say, because first term matches, second term matches, and sign in the middle opposite. So square of the first term minus square of second term. Or you can do simplified, simple method multiplying, no issue at all. And iota square is very clear, minus 1. So this is minus 1. So I get a plus 6 finally. And square of a and square of 2 become 4 into iota square. And iota square give you what, students? Minus 1. So 3a iota plus 6 over, this is becoming a to power 2 minus 4. But we have to convert in Cartesian form. So then we are bound to split them. And let's see what splitting comes finally. And when I split it, okay, split. So real part I write first by the denominator. And then I write the complex part up and by the denominator. And iota, I'm writing it here. This is called the required form, what he was asking us. Now he's saying find exact value of a when it's conjugate. Argument of conjugate of u star. U star is called conjugate. So actually this is a u. Then what is a conjugate, students? So u star is actually everything remains same. No change will come. Only the sign with iota will change. It means this iota sign plus will become minus. Okay, now what to do? We have to find argument of this. And what is a normal way of argument, students? Argument of u star is very clear. A tan inverse I, like I coefficient, whatever I coefficient, keep it up. And I mean complex part by the real part. Complex part and real part is this. So let's start. 3a over a square minus 4 and 6 over a square minus 4, but minus sign is still there. And wait a minute. I write minus here. Now, students, what is the technique? This is given by him pi by 3 and tan inverse. And you know, denominator will cancel out like this. And what left? Tan inverse, negative 3a by 6. After this, what is the next process? This tan inverse will go there. It will become tan pi by 3 and negative a by 2 because this 3 and 6 will cancel. And tan pi by 3, if you check it carefully, this is actually equals to, you know, this is, so this come root 3 by 3. Okay, root 3 by 3. And after this, if you check it, if you find it, so finally, if you type in calculator, so it is coming, 1 minute, let me check, students. Yeah. So it is coming root 3, sorry, only. Root 3 only, not the root 3 by 3. Root 3 comes. So minus a over 2 cross multiply. So it becomes a is equals to negative 2 root 3. So alhamdulillah rabbil alameen, the point is clear. And there's next part we have given here, complex number, that Argand diagram you just sketch and then shade. And if you look at carefully, he's saying on a sketch Argand diagram, shade the region which representing complex number and two inequalities. These kind of questions, students, whenever we try, we have to make a rough idea. How to make a rough idea? Let's start Z negative. Okay, and I'm writing here 0 plus 2 iota and Z negative 1 plus iota. For sake of knowledge, this minus sign is fixed. Similarly, this minus sign is fixed. So we have to produce somehow negative signs. Okay, and this, whenever modulus appears on both sides, is called perpendicular bisector. And let's talk about a second one. Second one is Z negative 2 plus iota and modulus and less than equals to 2. This is called, against this negative sign is fixed. This is called center of circle. And this is called radius of circle. Okay. Now, before to start this one, we must know one thing, that that what is the position, what's the location, how we can draw. So best technique, first you rough draw. Rough drawing is very clear. This is a 2 and iota. It means if I make a rough idea, it's very clear. Okay, I make it here. 2 and 1. So it means 1, 2, and 1. So this is x is 2, y is 1. So this is a point. We are getting it here. And the radius is 2. So naturally this gap is also 2. So it means 100% circle will become like this. Reason is very clear, because radius is 2 and center this is 2. So this means circle must touch y-axis. And radius is 2, so one value up and one value down. Make sure it is very, very clear. And this is gap 2. This is gap 2. So short story, total gap is 3 from x above x-axis. This is a rough idea for this one. What about rough idea of this one? So this is perpendicular bisector. Where is a 0 and 2 iota? 0 to iota is, we can say there that this is 0 and 2 iota. It means I show you blue line. This is a blue point, which I locate for it. Where is 1, 1? X is 1, Y is 1. So this point is very clear, because 1, 1. So it means it will go like this, like this. So let's try, because we put a needle here and put needle here, and it will look like this. Anyway, let's try to do it. Okay, so first of all, okay, and one point is very clear. This is a center of circle. Take a scale and make a here. Okay, 1 minute, please. I think clear. So make all right. And now how to make it x-axis? I will draw in the middle. Logic. What is the logic behind it? Because it is a very clear, because you can say that the diameter, the radius is 2. How much this gap? 1 and 1, 1 equals to each other. So I got it. Alhamdulillah Rabbil Alameen. And this point is 1 and this point is 2, and exactly here is a 3. Okay. And I hope so. This is very clear. 1 and 2. All right. So you can see that you can understanding that is close to accurate. Now this is done. Now let's talk about perpendicular bisector. Very interesting part is what here, because this is 1 and this is a 2. Okay. Total is 3. And second number, one more thing, whenever this is equals to each other, like This is a way, well, locate the point, please. One point is here. Second point is 1, 1. I repeat, this 1, 1 is this. This x is 0, y2 is very, very clear. And when I draw a perpendicular bisector of these 2 points, students, it will become like this. And for your knowledge, I just tell one thing, which is a very, very important to understand. It means put a needle here, I make this kind of arc and this kind of arc. If I put needle here, I get this arc. I show you what I'm saying. I put needle at this point, I get this arc. When I put a needle here, I get this arc, and then you drew. I hope so you understood how I done it. Okay. Now, very interesting point. This exactly above this point. How I'm confident, because it's a very, very clear, because I can prove it, because this is a square of 1 box. You can see this 1, 1, and this is a square of 2 box, 2, 2. You can see, okay, and that is why it is you can exactly cutting from there. So this is a reason behind it. Now, what a question he's asking after this. He's asking that less than, what is called less than inside circle. It means inside circle is my answer. What about this? Whenever less comes, that point we have to shade towards. This is 0, 2 is this one. So shading part is which one? I'm going to show you. This is shading part. Okay, this is done. So 4 marks are confirmed for this. And let's talk about the next part. And now I think so I can erase it. This thing is okay. Or you can keep as it is, better to erase, no problem at all. Calculate least argument value of the argument. Argument stand for what? What is like a shortest angle for the x-axis. Shortest angle with x-axis is called argument. This is a definition. So which point of shader region, which point of shader region is the closest angle? For example, this point, if I locate this point, so angle with this is, line is 90 degree. This line point is wrong. If I take this point, then if I join it here, and this angle is a argument, is again wrong. This is not smallest. So if I make it this, if I make a point somewhere here and join a line, so this is argument, but it still is not a least one. So at this point, if I make a line, so this is called angle, but still not least. So I think this point is the least. So I'm going to join one blue line from here till here. Okay, so this is a angle we are looking for. This angle is called least. So we are looking for this angle, okay? So alpha. So I think I can very clear sense this triangle, I can get it from here. And this triangle I'm making here, and triangle is like this. There's a 3 gap, there's a 1 gap, and there's alpha. How I know this? Sorry, there's a 2. There's a 2. How come this 2? You can see this gap is 2 and this gap is 3. Logic, because this radius is 2 and there's a 1 already. So 2 plus 1, 3. So I think very clear approach. So tan alpha equals to opposite by adjacent, and tan inverse 3 by 2. And simply type in calculator and get our answer. And tan inverse 3 by 2, the answer is coming. Although he did not bound us, you can write in radian or you can write in degree mode, so no problem at all. So answer is 56.3 degree with x-axis. So alhamdulillahi rabbil alameen. I hope so. The whole idea of the paper is very, very clear.